Ready to go live. Hey, I think we're live. Yes, we're live.
Sweet.
All right.
If this were a proper show, I would say something like, welcome to the technology behind Web3 or something with Privy, but it's not. We're just going to work on something together. I'm Chad. I work at BlueYard, and I have Asta and Ben here from Privy. Where are you guys calling in from? Is that even what you say? I don't know. I'm old. Sounds like a radio person, right?
I'm calling in from San Francisco, where I live.
Oh, nice.
And I'm calling in from New York, where I now live.
Great. I'm in Arkansas.
Oh,
Yeah, actually in Arkansas. So what we're going to do here, this is a new series, unless I completely destroy this one and we decide not to do it again. This is the first one. So thank you for being guinea pigs, you two. But the idea is that there isn't really enough technical content available about this whole world of Web3 or whatever we want to call it. It's very easy to find podcasts where people are talking about politics and innovation and technology. But I learn better when I actually get to see how things work. So we're going to start talking to people and looking at what they're working on and asking questions and hopefully providing an educational resource. If nothing else, we're going to have fun. So today we are going to look at Privy, and we're going to build up a demo that I guess is sort of already exists, but we're going to show how to use Privy to safely store sensitive information and use it. Yeah.
yes.
Perfect.
Does one of you want to talk about why Privy exists and what it is?
I'll go ahead and take that one. Yeah, so we're here building great, easy to use developer tooling to kind of give you a way to understand more about your users and build for users as actual people as opposed to just wallet addresses. And this is really discovering that, hey, there's this tension between taking on data to be able to build products for your users and deliver great user experience versus protecting your users' privacy. And we think there's a third way, which is if you build really great, easy to use developer infrastructure, you can both provide sort of thoughtful primitives that pave the way for user data privacy while also letting users share information about them as people so that apps can provide a better experience. So that's where sort of Privy comes in as the API to help you take on and manage user data in Web3 in a private and end-to-end encrypted way. And the biggest thing that I love about sort of the product that we're building is just how simple the interface is. It's privy.put, privy.get to link off-chain data to on-chain addresses. So we're here to give Privy a spin and show you what you can do.
Cool. I love the approach of trying to make the right thing the easiest thing to do. And you mentioned the tension thing. I used to work on Wunderlist, which was fairly well known for being a really nice, usable product from a UX and design perspective. When we started that, I would say we were too ignorant to even know there was a tension. So, on all sorts of data, we tried to be responsible with it. But toward the end of the time that we were running with Wunderlist is when GDPR was introduced. And that's when everyone really started thinking about, wow, this is scary, storing this stuff. And what most of us did at that time was just decide, okay, we're not going to take on the data and therefore we're not going to have the same features that we could have had otherwise. So great to see this.
What's an example of a feature that you wish you could have built?
Oh, well, on Wunderlist, I don't think there's anything I can specifically point out. It's more along the lines of like new products that we were starting to look at, particularly around machine learning, where you want to take in all this interesting stuff and let's say help people figure out or help figure out what kind of list someone's creating so you can provide domain specific task management for a certain area. We did a bunch of analysis of text that we could see like clusters of types of tasks that people were storing. For example, there was a difference between places you might want to visit on a trip versus packing for the trip. Those are two different types of lists. And the stuff that you could then surface based on, this sort of understanding is really powerful. But, we started to sort of shy away from doing anything like that because it's complicated,
It really is.
Yeah.
Yeah, that makes a lot of sense.
So how should we start? Do you want to start looking at code, and then as we go, we can talk about how it works?
Yeah, I was thinking we would start by sort of the same way anyone would start, which is they would head over to like our Privy admin dashboard or console and start configuring some information there, and then they would hook up clients to that. So I figured we could start by looking at the console.
Cool.
Yeah, let's do that. Ben, I'll leave it to you to share your screen.
Cool. Doing so now.
Jinx, Chad, you owe me a soda.
Can you see my screen?
Yes.
Yes.
Sweet. So when you go head over to console.privy.io and you would create an account and sign in, this is like the first page you'd see, just some information on our documentation, where to go. But the first thing that we're going to do is we're going to create some fields. So fields in Privy is like the most atomic unit of data that you have. It's just an individual field that you can name anything. So we'll go through and I should actually take a step back. The demo that we're building is something that we call the Privy Pii demo, which is just like a really simple web page where a user would log in with their wallet and they would be filling out some like Pii data that could be associated with that wallet address.
What
so
is
The idea is you can personally identifiable information.
Okay, so scary data.
Yeah. And I think of it like sort of this is your user profile. Like this is the data that like why is personal identifiable information so sensitive and important, especially in Web3. As you auth onto products one after another with your wallet address, this is like your public like bank account, your assets and transactions that are all publicly visible. And so doxing yourself and linking your real name and your address and your birthday and et cetera to that is something that's it makes that information especially sensitive. So I think that this idea is that you can take this profile with you, link it to an address, take that data with you from place to place, and it's private and secure.
Cool. Yeah, so now you're setting up like a schema as if you're configuring a database table.
That's correct. Yeah. Oops, I accidentally updated this rather than creating a new one. Yeah, so in this PII app that we'll use here, we're going to just take on these following fields. So notably, you would have like an email address possibly that would be something that is, something you wouldn't want to leak, but also this is just, kind of standard information that might be associated with a user profile. So what I did is I went through and created the fields. I'm using the defaults for the permissioning here. And what this means is that folks with like requesters with an admin role or the individual user themselves would have read and write roles. So given that I'm logged into the console right now, I am by default, I have an admin role. And then the end user themselves, the person that would be using this app would be assigned this self role. And so again, this just is the permissioning system around us that would only allow either the admin or the user themselves to read and write this data. And we could even, for the purpose of this demo, there is no admin changing any data. So we actually could remove the ability for the admin here to be able to write, but we will use it for the read. So in any event, I came in here, I created, this is like, Chad, like you said, this is what would be more or less your database schema here. It's kind of like a key value store for a lot of these items. And so we went ahead and created that. The other thing I would normally do, but I've already done this in this app, is come over and generate new API keys. And this would be what I'm going to configure the front end clients with so they can actually communicate with the API and authenticate themselves. Cool. So now that we have, also let's just take a look really quickly at what the demo. So this is a demo that already exists. So there's already going to be some React code in here. And the idea is that we will log in with our MetaMask account, and then that would be our wallet login. We'd be able to add our user profile information. So this functionality is currently not working, and that is because I have removed certain snippets of the code that we will now go through and take a look at and fix. And that will be the Privy bits.
Cool.
Cool. So first of all, before we get started, is there any questions on any of that stuff so far?
I don't think so. I mean, I guess it sounds like, if I'm extrapolating from what I've seen so far, that you're creating this like end-to-end encrypted key value store or relational store that we're going to interact with via an API from JavaScript in the browser.
Yeah, exactly. So what I just showed was like an admin dashboard for that API, but what we'll be doing from now on is communicating with the API through our front-end browser clients. We actually have 2 JavaScript clients at the moment that can communicate with the API that we support. One is for Node.js, that's more geared towards something that you would use in a Node app, like on a backend. And then we have a browser client, and we'll be working with the browser client here today.
Great. Makes sense. Cool.
Sweet. Okay, so again, there's a lot of code here already. I didn't want to spend all day writing sort of incidental code, so the important bits is what we'll fill out. And so the very first thing that we're going to do is I have this React session component here, and this thing is going to be responsible for like authenticating the MetaMask user with the Privy API, getting them an access token so they can actually read and write data to and from the API. And so the very first thing that we'll do here is we're going to instantiate a couple of objects that come from the, let me delete this, that come from the Privy client themselves. So this is our Privy browser client. We have this object here called a CV session. So this is CV stands for sign in with Ethereum. And we're going to just create a new one of these. And if I remember correctly, we need to, oh, actually, this is good. Yeah, so we will need one of the config values, which is, I believe it is stored in this file. Nope, this file. We need our API key. So this is the thing that I already went and configured from previously before we got started here, which is the API key that's assigned to me in the console. So this is what I'll use so that the front-end app knows which account that the request belonged to. And this is going to be, I believe, config. So now that we have our API key, come in and give this to the, I'm just referencing some of this code as well from before. We'll create this object, and then we're actually going to create the Privy client itself. So I'll elaborate in a second what this object is for, why it's necessary, and what specifically it's doing. But first, let me just create the Privy client here.
Whenever you do live demoing, you must be very glad that you took a typing class at some point, right? You're clearly a real typist, not a pecker. So I'm assuming that the Privy JavaScript libraries are on NPM or whatever. And they're just normal packages that you
install. Yeah, exactly. Privy-io/Privy browser will get you this exact package.
Yeah, and actually this demo is using a slightly outdated version, but the APIs will all be the same. But yeah, it would just be an npm install at privy.io / in this case privy-browser. So I want to take just a second to talk about what this CV session client is. So this thing is going to be responsible for taking in the MetaMask provider in this case and performing some wallet operations, namely a signing operation. And it will handle logging a user in based on like, a wallet that they have and a challenge that we will issue them. And so this is going to be like the Privy API backend talking directly to the user's wallet. So if I'm building a website and I'm the one who's building this this form where we're going to accept some user PII's data behind the scenes. The interesting thing here is that the end user would be talking directly to Privy to store their data. It's all going to be encrypted. They're not going through a middleman. They're not going through this this Privy customer server. They would be going directly to Privy. So data and encrypted, and it's not funneling through anyone else's servers except our own. So this object here takes care of all of that, and we implemented the relatively recent sign-in with Ethereum standard for how to actually do like user authentication using wallet challenges and wallet signatures. So
is this class or whatever this is called in TypeScript part of the Privy library, or is this pulled in from somewhere else? This sign in with
yeah. So these two things that I'm instantiating right here are pulled in from the Privy library, and so there's our documentation which I can point folks to real quick, docs.privy.io. It'll talk about those in here, and we're going to be using, this is the quick start, but we're going to be using more or less something very similar to this. And yeah, so these two objects do come from that library. The rest of this code here is some wrapper code that we wrote for the purposes of this demo. We could have done all of this today, but it just would have been a lot, and not all of it would be exactly related to the Privy bits. So I am trying to scope, like narrow in more on just the Privy pieces. But yes,
do me a favor and show me where provider is instantiated, just so I really understand
where
that came from.
So that I believe comes from somewhere. Actually, let's just search for it. Yes, so it's a little bit obfuscated at the moment, but this is again some of the React code that I didn't want to have to go too deep in today. But so we're using React hooks here, and we created our own session hook for the purposes of this demo, and that's going to create and instantiate an object of this, what we were just looking at a second ago, session, which has a few of these helpers. And so what this allows us to do is later in our React components, we can call use session, and it's going to give us an instance of this object back. And so we have these nice little helpers like get the user's address, check whether or not they're authenticated. We'll initialize the client, which will actually do the initial check and then run, this will actually do the thing where it runs the authentication step where the users have to sign a challenge. And we'll actually see that in the UI here shortly. But anyways, this is going to be created sort of behind the scenes. And so what actually ends up calling this is the hook. And then I'll show you where that initially gets used, which is, I believe in this app page here, we have this use session. This will probably be the first time that this gets called. And it'll be an instance of that object that came from the create context. So this is some sort of there's a few layers of indirection here. This is kind of your standard React stuff. I
have to resist the temptation to ask you to teach me how React works, because my brain is not good enough for it. I think I'm too old for React, maybe.
Yeah.
I've tried a couple times.
I do find this thing about front-end programming, which is there's all this new stuff that comes out every 6 months. And so you're always a beginner, which is kind of cool.
Yeah, it's interesting that your takeaway from that is that it's cool.
It can be when you have some aha moments, and other times it's frustrating to have to keep up. But and then just one last note on that. You asked the provider, it's window.ethereum, which is what MetaMask itself injects into the browser. So this is definitely operating under the assumption that MetaMask is being used here.
Cool.
Sweet. So now that we've, so this is what that would look like. Instantiating these objects. The Privy client requires a session. That's what's going to be connected to the API and actually have the end user authenticated. It's going to manage like an access token. We have other types of sessions, but this demo is going to be using Metamask Logging. So now that I have that, let's go back to the browser here, and I believe this should hopefully prompt up my MetaMask, and this is going to be the sign in with Ethereum standard here. So this is like the challenge being issued, and I'm going to sign this message. This is configured to hit production. So even though I'm running this on localhost here, the API it's actually communicating with is a real production account that I'm using against production. So we're sort of testing against our production API. And so this is my user address here. As you can see, there's no information filled out in this PII form at all yet. And so we go to edit to do so. But the code is going to be broken right now because I stripped out a bunch of pieces so that we could go fill it in. But the idea is, of course, that we would, the idea is that we would, be able to fill out, and this would basically sort of be like a user settings page, you can imagine, or some sort of user profile. Mm-hmm. So we'll start in the edit form. where we have some errors. So this is a function that does not exist at the moment. And this is also a function that does not exist at the moment. I ripped some code out of here, but the general high-level code overview here is that we're exporting this edit user page component. This thing is going to instantiate and make some API calls to actually fetch any existing data back for that particular logged in user. So whatever my MetaMask user is that I'm logged in with, and then edit or render this form, and this form will allow users to create or update whatever information has been stored in their profile. And so we'll need to start filling out some of that information.
Cool.
So the first thing we did is, if you remember in the console UI, we went through and we created each one of these fields: name, username, email, website bio, and avatar. So this is just me creating some React state that will hold these values. And we have this helper function here, submit enable. This is just going to be like, if the user has some value set for all of these fields, then like the submit button will be enabled. Otherwise, it won't. So this is kind of just our way of saying that each one of these fields is required in the form. And this helper function will be responsible for actually updating the React state here. So what we don't have here is we don't have any of the actual calls to either get the initial set of data from Privy, and we don't have the functions that will actually go and update when the user submits the form. So that's what this on submit will be, and as well as the on avatar update. So let's go ahead and start creating, we'll start building these. I'm gonna start with upload avatar, which avatar is a file. So unlike all of these other fields that are just, your standard classic simple strings, we actually are going to be expecting, I believe, a file object here. And then we will have to go through and upload that file. So to double check on that, I'm just going to see where this on submit function is used and what is being passed. Or no, sorry, not the on submit, it's the on avatar update, which is in this file upload form field. And yes, it is getting an instance of a file. We have this function in Privy called privy.put. I don't know why React, or why that's getting auto completed.
Privy logo.put.
Yeah, and so privy.put is used for putting a form field, and
do we have to instantiate the client? Maybe that's why it's not showing up.
Yes, I'm going to get to that one second. What I was going to explain here is that privy.put is the standard put method that we use for writing most data, but it's actually not what's used for files. So we also have this put file function, and the reason that this is complaining is because we actually need to instantiate it, but it already is instantiated in this session that comes from the React hook that I sort of described and showed you earlier in that sessions file. So we'll have an instance of Privy. So if you remember, we instantiated this instance of Privy here. And this session is now, this object is available to all of the React clients via this React hook. So I can actually now reference this and we'll get nice typing. So this is actually going to show me what is expected here from put file. And so user ID, and then the field that we're writing to, which we named avatar in the console, and a blob, which is a super class of this file object here. So the user ID would come from the session, and that's the session.address, I believe, is the, session.address is what the currently logged in user would be. And then we will write to the avatar field, and then we're going to put the file object. And this is all going to be an asynchronous function. And
does that address end up being your wallet address? Yeah.
Yes, exactly. So let's go back to the session object just very briefly here. This is the getter for that. And this is going to come from this property. And this property, when you actually go through, and I believe, so we'll authenticate. And then the CV object that comes with Privy has this address method on it. And that's going to actually perform a sort of a lower level call to the MetaMask provider to get the user's address. That'll be returned here. And then we just set set that on this object. And again, this object is exposed to any React component that we have.
Cool.
Sweet. So here's an error here because this is not an async function. And at this point, we more or less have the upload avatar function callback written, but I believe there might be some state that we would want to update here.
What you're doing here is what I used to call error-driven development, where you've got errors, and you have to make the errors go away.
Exactly.
Rather than test-driven development, because you don't have to write tests.
Yeah, so we have something that looks like this, but this might be from the other component.
I feel like most programming is error-driven development.
Yeah, that's true. We just don't call it that.
Yeah, you write it and you hope it works, but it never does. And then you fix it and then it does.
Yeah. So what we're doing here is we are actually storing the file identifier that we get back from this call to put file, and we're storing that in the state. Which, if I don't, it's been a while since I worked with this demo. If I recall correctly, that's not really used for much, so I don't want to elaborate too much on that. But I believe this is the code that we had here for that. So that's one function that we implemented and we called, and then the other one is the save user data. So this is what will get called when we actually submit the form. And we have access to the user data, which is the React state that we'll use to post the form. And so, as I mentioned earlier, we also have this put method on our Privy client. And this is similar to the put file, but this is going to work with, instead of file objects, this will just be working with plain strings. So again, we'll pass the user's address as the user ID. And then this time we are going to have a list of objects for each one of these fields. So I believe I'll have to refresh my memory on a couple things, but yeah, so we're going to be putting the user's address and a list of a bunch of data here. So we'll be placing, start with like name, for instance, and the value is going to be the React state dot name.
Mm-hmm.
We're going to do this for each of these fields.
Right. You said strings, and I know these are strings. Is it always strings, or do you have some sort of data typing that you can specify on the fields in the back end?
Yeah, that's a great question. As of now, the only two things we support are files and strings, and that'll be changing likely in the future as we build out more advanced features. But yeah, as of today, this is sort of more of a naive key value store where we would just be getting strings back for all of our keys.
Cool. Yeah, so now you have the fun of copying and pasting field names.
Yeah.
All right. Yeah. Simple enough, though.
Nothing too advanced going on here. I think the most interesting part is
I think you have left out the word privy, where you said session.put. You want session.privy.put on line 42, right?
you are correct. And check this type signature here, and it'll tell you, yeah, exactly, this can accept the variant of this function I'm using, which has a few overloaded signatures, but the one that I'm using here is the list of these field and value objects.
Nice.
Yeah, cool. So I'm checking some of the code I deleted from here earlier just to refresh my memory, but this more or less looks right, minus maybe any error handling that we have. And then I believe after the user saves data, we want to redirect them back to the sort of index page. I believe we can do simply using the router that was pulled in right here on line 16. But we need to do this after we get back a response. And right now, I actually am not going to use these response objects. So the response would return me back sort of like a reference to each one of these fields in Privy. It has a few extra attributes on it. You can see it's this field instance type.
Like it gives you some status information about what it did, or?
Well, in terms of status, I mean, this call would fail if anything went wrong. So this is going to be sort of like an atomic operation here. It's either all going to succeed or not. So
okay.
The status here would just be like if this request, if it failed, if an exception gets raised, then there's an issue. I'm going to assume right now that there's no exception that's going to be raised. But that would sort of be more or less the status. Then if there's not an exception that gets raised, yeah, we get back a list of objects. There's some properties on those objects, like some, I believe, like timestamps and a few other things like that, and a few ways of accessing the data. You can access like a raw byte array, or you can access it as a plain text string. Or in the case of files, you can access like the file blob.
Cool. Is the raw byte array so that you can deal with different encodings, or is that handled with strings?
It's currently really only something that would be useful for files. I see no current real use case to use that for like these simple values.
Yeah.
But if there's any context where working with like the raw byte data is better, then it is available. But yeah, as of right now, really the only place that would probably make sense is if you're working with the raw binary data from files. Cool. So let's just see where we're at now. This is see if we at least got rid of some of these errors. We did. So now we see this form, and I believe we can fill out the form.
You're typing your PII right into the live stream.
Now, if we pull up the console here, I see no errors as of now, so that's good. It looks like our React code is all there. Actually, well, I missed the network request, but that's okay. Let's see if everything is stitched together. Cool. So it seems like the put part worked, and we can actually go into the console and verify that. So if we go down to this, our data tab here, see now we have one user that exists, and this is the data that I just filled out.
Yeah, maybe a note on permissioning here is, the permissions on this data are, as you saw when Ben set up the fields in the schema initially, set to self and admin. So that's granting permission for the admin user who's here interacting with the console and is the developer who's building the app to be able to access that data. So if Ben, if you went into fields and, for example, changed the permissions to self only, you would find that we're no longer able to access that data in the console.
Yes.
And would you say that it would be more common that you wouldn't have admin? Because you're talking about like if I'm a company building something that's using Privy, I'm setting this up, and admin means me as the developer, right?
We find that lots of customers have different needs around this.
Mm-hmm.
So some are looking for this transition of permissions from, say, user only to user shares with company to actually we just want only the users to put this information in via their front end where it's end-to-end encrypted directly in their browser, and then pull it back in order to have that sort of front-end customized experience, but we never want to see it.
Right. Yeah, cool.
Yeah. Sweet. So now if we go back to this page, we're not seeing those values. And again, the reason is because I deleted the code that would do so that we can go and implement that now.
Yeah. Am I guessing right that it's going to be something like privy.get?
Yes. Yeah.
All right. That's so smart.
Sticking with the classic get and put terminology from key value stores. Yeah. So cool.
And when you changed the fields, you said you missed the network request, so we weren't able to see it. But had you clicked it, you would have seen some encrypted blob of junk.
Yeah, and
fire, right?
yeah, absolutely. And once we, so yeah, we can actually go and take a look at that in a second too. Once we upload or implement the calls to fetch the data back, we can take a look at what that data actually looks like. All right, so this is now the index file, this home page of this app, and similarly to the other page, we're missing some calls that would take place in here that would hydrate the set of data that's being used for the component to show users. So let's go and do that now. This is sort of a React thing, but this is the way to sort of naively fetch some information on component render or component mounting. So this will just run, this function will run the very first time that this component is written to the page. And let's take a look. So we want to do similarly to before. We have the session object that we're grabbing from the hook, and we're going to grab fields for the user's ID. So
it's a very similar API as put.
One interesting thing here that will be slightly more involved is the call to grab and render a file, because that works with some raw binary data and some object URLs we'll have to create client side. But the other values that are simple strings are quite straightforward. So we have some nice destructuring that can take place here. So we can do name, username.
How did we ever use languages that didn't do destructuring? It makes me smile every time. Although I didn't just smile, did I? I was smiling on the inside, I promise.
All right, so this is one of the signatures that can be used with Git, and so we'll get these objects back in the same order that we requested them, which is what enables this sort of nice destructuring syntax here. And one thing that we might have issues with is that each one of these objects could be null. And the reason for that is that we're working with a database with fields here. There's no sort of constraint on the backend that data would always be present for one of these fields. So it's possible, like for some users, that they might not have one of these attributes, and therefore, if you see on this signature complaining about it could be null, and that's the reason for that. But we'll get there in a second. Let me refresh my memory on this. Yes, so we have this helper function that we wrote that's going to take this response and translate that into values that are more appropriate for like the React state, as well as deal with the typing information from possible null values. So this, I believe, comes from actually, sorry, that was used on the edit page. We didn't implement yet. So this right here, I have to refresh my memory again. Okay. So this is even simpler then. I'm going to go back to that syntax we had. So the React state was actually defined to be either null or one of these field instance data. The field instance object is like the type that you get back from this get call. So we can actually just go and set this directly on the React state.
It really is a good thing you decided not to build this from scratch, because even now, like 90% of the time you're doing React stuff as opposed to Privy stuff, right?
Exactly, yeah. All right.
Did you forget to use await?
Oh, thank you. You're correct. There we go. Why is this complaining now? Oh, right. Use effect can't take an async function. So we can just wrap this in our own async function, or we could use promises, but I'm just going to wrap it in our own async function in here. All right, sweet. So this is going to go and actually grab the data for each one of these fields from the API using this address as the user ID. When it gets those fields back, it's going to set it in the React state. That'll cause the components re-render. It'll pass that to this user show, which is going to list the actual HTML to the page. Now, we did not do the file piece yet, but I'm going to save that for later. And in the meantime, let's just see if the rest of this is working. And it appears to be working. So,
all right.
as you mentioned a moment ago, we could look at some of the network requests and talk about a little bit of what's happening from a cryptography perspective, if that's interesting, Chad. I don't know if you have questions around that.
Yeah, definitely. If nothing else, it's part of the demo to see, like, yes, you really can't see what the values are.
Right. So yeah, so each one of these fields, so like this is a name field, for instance, we have a few pieces of information. Earlier, I mentioned some of the other attributes on those field instance objects. The integrity hash is another one that might be interesting. We can talk a bit about that. But as you can see here, the value is definitely not the string, Ben in this case. It's this huge, long string of nonsense. So like we mentioned earlier, everything's end-to-end encrypted. So all of this stuff will be encrypted client-side, written to the server, pulled back and decrypted client-side at some later point in time.
Yeah, and just a little bit of context in terms of what's happening under the hood there. I think, again, as I said, like one of the things I really appreciate is this super simple privy.put, privy.get interface in order to store data. However, it's hiding a ton of complexity under the hood. Privy.get, for instance, is making a request to both the Privy API for encrypted blob contents, as well as the Privy KMS for keys that are basically unique for each data item that is stored with Privy. And there's a permissions evaluation that happens both to gate data retrieval as well as key retrieval. And so the keys are sent to people who have permission to access the data sent to the browser. And then the encrypted data is also gated by that permissions check and then sent to the browser. And in the Privy browser client library, which is also backed by the Privy crypto library, both of which are open source on our GitHub and available on NPM. Right there at the endpoint in the user's browser, the key is used to decrypt the user data. And so the sense is like things are end-to-end encrypted and protected by permissions, which can be configured either within the Privy API or within the browser. And so actually, I'm wondering if you're able to see the keys being like the network request for the keys or no, but that is what's happening under the hood there.
Yeah, so we can definitely take a look at that. Yeah, it's true. I've been very caught up in trying to get the code to work that I'm selling some of that magic short. But yeah, so much of what's happening here that's interesting is the fact that this is not just your standard database. This is all end-to-end encrypted. So a lot more going on. But yes, we can. So this is the request I'm showing you here is the first one that actually just goes and grabs all the values for the field back. There's another request that happens that actually goes through and passes some information back to the KMS for key retrieval.
KMS key management system?
Management service.
Service? Okay, thanks.
Yeah.
And that is a Privy proprietary thing that you've built on the back end. True?
Yeah, and the idea really is for that to become more of an open system where the idea is for us to be able to, I think that it's really interesting that in an open data world, permissions are gated through encryption. It's like through cryptography. And the sort of the key store is really deeply tied to permissions evaluation, because that is sort of the thing that gates like, kind of open data, even if encrypted. Yeah, maybe the sense is like right now we run the key management service on our servers, but we're looking towards ways to really open that up in a sort of more decentralized and trustless way.
Cool. And the network request, I saw what looked like 5 keys coming back. Am I right, or am I misinterpreting what I saw?
You are right.
For each of the pieces of data.
Cool. So there really is, you said that really quickly, but there really is a separate key for every field.
Yeah, and the thinking behind this is that because we have this sort of insight, at least it feels pretty cool to kind of connect the dots and go like, oh, actually in Web3, permissions and access control is gated through cryptography. We want to match the granularity of permissions with the granularity of data keys.
Yeah, really cool. Interesting.
Yeah.
A higher level question for you. You're saying Web3, and of course we're looking at Metamask, and so it's definitely Web3 stuff we're doing right now. How much of this could be applicable if you were using Metamask? Like if you were doing something that wasn't in the crypto/Web3 world?
Yeah, that's a great question. Interestingly, actually, everything that we have here today, except for maybe some of the stuff I showed earlier with like the CV session, which is definitely specific and coupled to Web3 and wallets. But if you take that piece away, the rest of this whole encryption protocol, writing the data, dealing with key management, none of that is actually specific at all to Web3. There's no there's no tokens involved. There's no there's no reads or writes to any blockchain. This is all happening just with basically pure cryptography.
Yeah, as it is, it resembles something like a proxy between you and your user data, or maybe like a data tokenization system. Mm-hmm. And I think that the thing that is really interesting from a Web3 perspective is that the signing with Ethereum integration, for instance, is actually really critical to some of our thinking around where we're going. Also, there's more details in the Privy mind map if you check out, I think, blog.privy.io. But the auth integration with Ethereum and with user wallets is a really critical component of this path to data sovereignty, where we can shift control of data back to users by linking directly to their wallets as sort of a pathway into this notion of a profile or account that users can take with them from dap to dap.
Cool. One question, like I'm just thinking about like everything that we had to do to get this working, and it's taken some time. We've been talking a lot, and that's really how programming is. We really have done like 3 big lines of code that were Privy related, and then done some configuration in the console. It is pretty amazing what you get for such a simple interface. That's something I love about this, and I think like Web3 up and down the stack, whether it be from a user perspective or like a normal consumer user or a developer perspective, UX is so poorly attended to usually. And it's really refreshing to see this. And I hope others take this as an example. Developer experience is so important. And like we were saying earlier, making the right thing be the easiest thing to do. Like I'd kind of rather do this than the alternative of storing it in my own database. I might, as a developer, I might be tempted to be lazy and put too much in here, I guess, but that's another problem. You did do some configuration in the console where you were setting up the fields. Is that something you always do through the GUI, or is there a command line thing or a programmatic way to do it?
Yeah, so earlier I mentioned, that's a great question. Earlier I mentioned that we have 2, actually they're pulled up right here, two client libraries today that we support. One is intended for the browser, and the biggest reason there's a split here is like the browser has a few extra tricks up its sleeve. Like for instance, it has the CV object that has to do with Metamask connections in the browser. But we also have this Privy Node client, and that is more something that is intended for working with more of the management side of Privy. So this thing definitely has all sorts of methods for dealing with changing permissions dynamically, creating, removing fields dynamically, adding or removing users from the back end programmatically, and then also can do everything that the Privy browser can do in terms of fetching or like reading or writing data. So yes, you can programmatically create those fields. You can do everything that you can do in the console, you can do outside of the console.
Cool. And do you have any sort of concept of like migrations? I guess there's not a lot you can do, but you're either adding or removing. You're not changing types because they're strings, right?
Yeah, so we don't have any like sort of first class support for migrations, but like two things on that. One is, I mean, it's intentionally simple, so we're not trying to replicate a full relational database or something that's just much more complex. We're trying to specifically keep a key value store that is really intended to be used only for sort of some of the most sensitive bits of information that are tied to users. At least today, that's the case. And so we don't have any way to, any first-class support, any like click buttons to run a migration or UIs around that. However, if you really did need to switch data over to a new field or change the permissions on, like say, everything that exists, you could use the Privy Node client to do that programmatically via some sort of script that you write on your own. Similarly to the browser one, you have these get methods, the Privy Node methods that are exposed for working with some of the more managerial things are like super simple. So it'd be, quite easy to do.
Yeah, I guess if you're thinking about things primarily or maybe exclusively on a per wallet basis, then some of the things I have in my head that I'm thinking, oh, it's a database, you don't really need them because it really is like.
Yeah, I'd think of it more like the users table.
Yeah, makes sense. And Asta, I think it was you earlier said something about users being able to take this data with them. So like right now I'm thinking about this anyway, from the perspective of a single developer that's building something where I've got users and I'm storing it in my users table. Is there an idea that the user data that's added could be accessible from other sites?
Yeah, exactly. The path forward here is very much, right now, data within Privy is connected to individual users, linked to say their on-chain accounts, and scoped to the specific the app. So it's sort of this representation of the user that has an app-based scoping that we plan on hoisting out of the app-specific scope into a more global state. And I think that's where you get sort of the power of interoperability and getting to take your data from place to place, and that sort of anybody who's plugging into the Privy ecosystem is able to get this representation of a kind of global decentralized data representation of a user beyond just what they have on chain.
Yeah, which the user is bringing with them as opposed to like fetching off of some centralized surveillance database that's being created by who knows what.
Yeah, exactly.
Yeah,
that's the path forward.
Cool. It strikes me that it's kind of crazy that doesn't already exist and hasn't for many, many years. But here we are. Yeah. So what else should we look at or talk about? I think we're getting close to time here. Like, I'm curious about, once the data's there, what else you can do with it, as a developer, for example. Like, I don't want to see it, but what are the ways that I normally interact with a users table? Like, I know you have the ability to send email to people without seeing it.
Yeah. A good time to transition Asta to show off some of those other demos.
Exactly. I was about to pull up screen sharing. Give me 1 second.
Cool.
Okay. So I have to set up some browser settings on my side. Actually, Ben, if you want to run through the demos on your screen, go to demos.privy.io, and we can just kind of do a walkthrough together.
Sure.
Demos.privy.io, which is publicly accessible.
Yeah, exactly.
But I can share.
Cool. I want to do. There we go.
Sweet. So just walking through a couple of the demos, if you're following along, feel free to go to demos.privy.io. And a few of the demos that I think are particularly interesting. There's the PII demo, which is a hosted version of what we just built with Ben, in the last 50 minutes. And the ones that I think are particularly cool that demonstrate what you can do with data are the Send Demo, Privy Flush, and Crypto Snoop. So the Send Demo is a demonstration of actions on encrypted user data that is shared with an app. And so here you can enter in your email address, sign up to this fake kind of demo company called Acme Corp, which is a Web3 gardening company. And from the admin panel here, you're actually able to, and there's a view admin button in the upper right corner, you're able to sort of send emails to users given just their Ethereum addresses or Web3 account addresses. And there's also some nice like templating magic that we have as a part of our email API. But the sort of crux of it is this is like a privy or an action that you can take on data that is custodied via privy. So here there's no visibility of the user's email through this like admin visualization, but we're still able to send emails and engage with our users and send the notifications.
Cool. So I could imagine you could also do stuff like push notifications in the back end and all sorts of things in the future.
Yeah, exactly. And I think that one thing that's really interesting more generally is like execution of or sort of this idea of actions on data that is sensitive or that's encrypted. And then back to the demos page, we also have a couple more demos to check out. One is Privy Flush, where you can send end-to-end encrypted files to yourself or a friend's wallet, which is, okay, it's really, I don't know if the audio works on this platform, but anybody who is trying this out, it's got this like amazing flush audio that goes along with it when you press send on a file, which is just amazing, and it like spins, and I kind of love it. So
for those that don't know, privy is slang, what, in the UK for Twitter?
Yeah,
is that right?
Yeah, and the sort of sense there is like it is a play on words. Like we are the piping for your data. We keep your data sort of off chain and out of the house, and we help you deal with it so that you don't have to.
Cool.
Yeah, I don't know if someone wants to volunteer a wallet address. Otherwise,
I will in a second, or actually maybe I can send it to you in the chat.
Yeah.
Where is
so
this?
For each of these, there was a link to code. I assume it's a GitHub link or something.
Yeah, so each one has the view code next to it. So in the case of what we're currently looking at, yep, these are all, I believe these are all Next.js apps using a combination of our two clients, the browser one and the node one.
Yeah, exactly.
Cool.
Cool. So, sweet. Then the last demo that is available is the Crypto Snoop demo. I mean, they're all there for you to see, but Crypto Snoop is also really awesome. It is some demonstration of both the Privy browser and the Privy node API, but the or at least it also demonstrates how to like one of the authentication formats. But the cool thing here is that you get to kind of watch another user's Ethereum account and get an email notification if the account balance changes. And so here we've integrated with like an email auth system so that you can log in directly with email, and then that takes you to sort of your Crypto Snoop account for where you can enter the addresses that you want to watch. And then, you'll get a notification if the account balance changes, which means like they did something interesting, and maybe you should go take a look and and see what activity that this interesting account has engaged in.
Fun. In fact, I'm going to go read that just to see how you watch the wallet address, which is not even a privy thing. But
yeah, we use some lovely sort of provider APIs and ping it on a regular interval, and then check the balances against the previous cached volume.
Great.
Yeah.
Sweet.
Cool.
Yeah, so I guess that's our hour, but super excited to have shared some of these demos with you and then built one of them, kind of live. And these demos are available for anybody who wants to check them out. They're online, hosted, and all the code is open source.
All right. Thank you so much for doing this. I have actually learned stuff, which is a sign of success. Hopefully it was worth your hour if only I learned something, but I'm guessing that's not going to be the case. And very much appreciated.
Yeah, thank you so much.
All right.